Hey everyone, welcome back to the channel. Today we're diving into one of the most essential topics in Java, threading and multithreading. In just 5 minutes you'll understand what threading is, why it's so important, and what happens when you use it, or don't use it in your Java programs. Whether you're a beginner or brushing up your skills, this video will give you a clear, practical understanding. Let's get started and see how threading can make your Java applications faster and more responsive. Start with the basics. What exactly is threading? In Java, a thread is the smallest unit of execution within a program. Think of it as a separate path that your code can take, running independently from other parts. Every Java program begins with a main thread which runs your main method, but you can create additional threads to let different parts of your program run at the same time. This is the foundation for multitasking in Java, and it's what makes complex, interactive applications possible. Let's look at a simple example. Imagine you have a class called myThread that extends thread. Inside, you override the run method to print a message. In your main method, you create a new myThread object and call start. This start method creates a new thread and runs the code and run, all while the main thread continues. This means two parts of your program are running at the same time, demonstrating the power of threading in action. Why should you use threading in your Java applications? The main reason is multitasking. Threading allows your program to perform multiple operations at the same time. For example, in a chat application, one thread can handle sending messages while another receives them. In a game, one thread might update graphics while another processes player input. This makes your applications faster, more responsive, and much more efficient overall. Let's take a closer look at a chat application. Imagine you're chatting with a friend. One thread is responsible for sending your messages while another is constantly listening for incoming messages. This way you can send and receive messages at the same time without any delays or interruptions. Threading makes this seamless experience possible, keeping your app smooth and interactive. Now think about a video game. One thread might be dedicated to updating the graphics on the screen, while another handles player input like keyboard or mouse actions. This separation means the game can respond instantly to your actions, even while complex graphics are being rendered. Threading is what makes modern games feel fast and responsive, giving players a smooth experience. By using threading, your application can handle multiple tasks at once, making it much faster and more efficient. Without threading, each task would have to wait for the previous one to finish, slowing everything down. Threading lets you take full advantage of your computer's processing power, especially on modern multi-core CPUs. Multithreading takes threading a step further. It means running multiple threads at the same time within a single program. Each thread can handle a different task, and the CPU divides its time among them. This leads to smoother performance and a better user experience, especially in complex applications. When you use threading, the CPU splits its time between all active threads. This is called concurrency. Even if you only have one CPU core, it can quickly switch between threads, giving the illusion that everything is happening at once. On multi-core systems, threads can truly run in parallel, making your applications even faster. Here's a real-world example. Imagine you're downloading a file in your app. One thread handles the download, another updates the progress bar, and a third responds to user clicks. Each thread works independently, so your app stays responsive and users can interact with it while the download continues in the background. That's the real power of multithreading, many threads working together efficiently. Your application can handle complex tasks, keep the user interface smooth, and make the most of your hardware. This is why multithreading is a must-have for modern, high-performance Java applications. But what happens if you don't use threading? Your program becomes single-threaded, meaning only one thing can happen at a time. If one task takes a long time, everything else has to wait. This can make your application feel slow and unresponsive, especially if you're doing something complex like loading data or processing files. Without threading, your program faces several problems. First, performance drops because tasks can't run in parallel. Second, the user interface can become unresponsive, freezing while waiting for tasks to finish. Third, you're not making full use of your CPU's capabilities, wasting valuable resources. Imagine a single-threaded program that loads a large file. While the file is loading, the entire application freezes. You can't click buttons, scroll, or interact with anything until the task is done. This is a common issue in older or poorly designed programs, and it's exactly what threading helps you avoid. Modern applications are expected to be fast and responsive. Users want to interact with your app at any time, even when it's busy processing data. Threading is what makes this possible, allowing background tasks to run without blocking the user interface. Today's computers have multiple CPU cores. Threading lets your program use all of them, running different threads on different cores at the same time. This boosts performance and makes your application feel much faster, especially when handling heavy workloads. Responsiveness is key for a good user experience. Threading ensures your app can keep responding to user actions even when it's busy with other tasks. This keeps users happy and makes your software feel modern and reliable. Let's compare. With threading, your app can download files, update the UI, and respond to clicks all at once. Without threading, each task waits for the previous one to finish, making the app slow and frustrating. The difference is clear. Threading is essential for modern development. To sum up, threading allows multiple tasks to run together, making your Java programs faster and more efficient. Multithreading means using several threads for even better performance. Without threading, your applications will be slow, unresponsive, and unable to take full advantage of modern hardware. Threading and multithreading are essential for building modern Java applications. They let you create fast, responsive, and efficient software that meets user expectations. If you want your programs to stand out, mastering threading is a must. Thanks for watching. Now you know what threading and multithreading are, why they matter, and how they can transform your Java applications. Keep practicing and you'll soon be building high-performance modern software. Stay tuned for more Java tips and tutorials.